Wow. Oh my gosh, Dane, that's amazing.
I'm going to turn the light off. It took ages.
I'm not surprised. That's so cool.
It doesn't fit on the windowsill because it's too wide, which is a bit annoying. But I might try and find a way to hang it. I don't know.
Does that have the tinfoil thing still in it?
It's still in there. Look, still well glamorous.
Oh. You know, you can do truly amazing things with willow when you soak them the evening before. You can just put them in a bathtub or something, and then they're so bendy and cool.
I was thinking about soaking them. I'd been doing it for like 2 hours. I just sort of had, I don't know, like some Netflix kind of binge box thing going on, and was just bent. And I thought I probably should have soaked them to make them, because they kept snapping.
Oh wow!
It's done now.
I still have last year's lantern in the background running there.
That's a good one.
I have been so busy this year. I haven't even managed to make a new lantern so far.
Good evening, everybody. Welcome to this session 6 of Glow Your Own. We're going to do a little bit of coding today, and then we're going to look at people's lanterns, and then we're going to talk about how to be involved in the Oxford Christmas Light Festival. So we will be doing a bit of coding. Let's introduce the team then. So we've got up, so Sophie, over to you. I'm going to pass on.
Thank you, Dane. Hello, everybody. Thank you so much for coming. It is lovely to see you all again. I'm Sophie. I'm sure you remember me by now. I work at Rutherford Appleton Laboratory. And as Dane said, we're going to be doing a little bit of coding. We don't have time to do all of the coding that you asked us how to do last week, but at the end we will share some links so you can find out for yourselves how to do those different things. So I also have brought along my friend Ryan, who works at RAL with me in RAL Space. Do you want to say hello, Ryan?
Hey, hello everyone. Like Sophie said, I work at RAL Space. I'm an electronic engineer, so sort of what you've been doing already and what you're doing today, I just sort of do it more for I get paid for it. So the main things that I do is sort of make stuff. So we make things for satellites essentially. So so instrumentation. So if you sort of try and do science in space, you have to have some sort of scientific instrument, and you have to make that, and you have to design it yourself. And that's kind of what I do. I sort of take the things that scientists want and try and build something that will be able to achieve that. And yeah, I'm also based at RAL along with Sophie. So I've done a few things a little bit like this before and played with Arduinos a lot. In fact, I have quite a few Arduinos just sitting on my desk doing random things. So
Great.
It becomes an obsession at some point. Yeah.
Thank you, Ryan. So Ryan will be able to help us with any coding and electronics throughout the day. We've also got Sarah. Do you want to say hi, Sarah? She's back again, doing all of the helping.
Hello. Sorry, I'm on the chat already. I'm already stopped paying attention, but I'm looking forward to seeing some of your lanterns later. Yeah, it's been really fun.
Thank you, Sarah. And we have Catherine. Say hi, Catherine.
Hi.
From Fusion Art, she'll be just reminding us how we can share it with the Christmas Light Festival, as will Tommy. Do you want to say hi, Tommy?
Hey. Hiya.
Sorry, it looked like you'd frozen a little bit there. So yeah, Tommy is here, and I'm sure he is.
I probably am.
I'm sure he's just as impressed with your lanterns as
Very much.
I am. Fab. So
yeah, looking really good.
Yeah, honestly, I can't wait to see all of your lanterns. The ones that I can see at the moment are amazing, both from a beautiful point of view and from a coding point of view. So you asked, we had a whole bunch of different suggestions for what we could do in terms of coding this week. There were far too many for us to be able to do all of them at the moment. So I've just picked one because it lets me talk about one of my favorite things in coding, a very useful thing called variables. So what we're going to do is we're going to use a button to change what pattern our lights flash in. Okay, so we're going to do it really, really simply just to start with together so you can see how it works. And then on your own, you can make the patterns fancier or do whatever you like. So I'm just going to share my screen. So if you all want to get a new circuit up on Tinkercad, so you all remember, go to Tinkercad and then click on circuit and then new circuit. I'm just going to make it so that I can see more of you while I'm doing this as well. Right, so can you all see my screen, my Tinkercad screen? Yeah? Okay, so to start with, we're just going to use, to make it simple because we don't have huge amounts of time today, we're just going to have a really simple circuit with one LED and one button. And you can add more LEDs and things later. So we need our breadboard, just like normal, and our Arduino. And then let's get an LED. What color LED should I use? Catherine said blue. That was a very definite blue from Catherine, so we'll definitely use a blue one. A blue one here, and then let's just get a resistor. So this is the circuit that we've been using, that we've used a lot before. I'm sure you all remember it, so I'm just giving you a chance to catch up. You all there? Give me a wave if you're there. You've got your circuit. Fantastic, brilliant. All right, so we want our resistor, and if you remember, we want a resistor to be about 220 ohms, like this. Then I'm going to connect the other pin of my LED to pin 4. Remember, that's a green one because that's going out. And then I'm going to complete my circuit by going from the ground there. So we've just got this really simple circuit for my LED. This is the circuit that we've done before. So the circuit we've done before, it's just the coding that's going to be new this time, okay? And then we need our button. So I'm going to pop the button in over here, remembering to put it so that it's over the little gap in the middle of your breadboard, okay? Over that little gap. And then we want to remember, you'll remember that we need to power our button. So we need to send some power to it. So I'm going to go from the buttons leg to the power line, to the long red line down here. And then I'm going to go from that red line on the breadboard down to this. And then I'm going to change where that is so that it's nice and straight because I like things being nice and straight. Okay. Then we just need to complete that circuit. You all with me? You wave or raise your hands or something. Fantastic. You are getting, honestly, Ryan, they've got I'm so impressed with how much they've learned in the last few weeks. So we need our resistor to go along there, and we're going to leave that as a 1 kilo ohm resistor, so we don't need to change that. And then we need to take, to go from our button back to our Arduino, and I'm gonna send it over here to pin 13, just because I feel like it. Oh. There we go. And I'm going to make it a yellow wire. So that's our circuit. We've got our LED going here, and then our button, our LED connected to pin 4, and our button, which is connected to pin 13. Okay, has everyone got this circuit? It's just like the ones that we've done before. Brilliant, fantastic. That was a very definite yes from Ben. Brilliant, I'm glad. So now the fun bit. Now what we're going to do is we are going to code it. So we press the code button up here so we can get our coding out, and we don't want their normal stuff. So we're just going to get rid of that. And what we're going to use to just, and so we need to, what I want to do is I want to be able to tell my LED either to be on, so just on all the time, or to flash on and off, okay? And I want to be able to control, to switch between those with the buttons. And the way we're going to do that is we're going to use something called a variable, which is down here. Now, variables are really, really useful in all kinds of code because it's a way of telling your computer to remember something. So it's like, computer, remember that the LED should be flashing, or computer, remember that the LED should just be on. All right, so if you click on the variables one, the pink purpley one here, and then create a variable, and we need to give it a name. Now, you can name it anything you want, almost anything you want. Doesn't really like it if you put spaces in it or dashes, but it's really sensible to name it something so you'll remember what it's doing. So I'm going to call mine pattern, because it's going to be the variable that makes the computer remember what pattern to flash the LED in. Okay, so once you've created it, you'll see that there are these things that come up, and you can use the variable pattern. You can change its value like this. And so the first bit of code we're going to do is we're going to set pattern to 0. So just bring that out and set our pattern to 0. Okay, is everybody with me? Give me a wave or raise your hand or something to let me know. So we've got loads to go through today. So fantastic. I can see some of you are there. So we are going to go through this bit quite quickly because I want to see all of your beautiful lanterns. But don't worry, because this is all being recorded. Is this being recorded, Dane?
Yeah, it's all recorded again.
Fantastic. So you will be able to watch online afterwards if there's a step that you miss. Okay, so we've set our pattern to 0. And then, just like we've done it before, we're going to use the control. We're going to use our repeat loop to set something up so that it's going to happen, so that everything inside our loop is going to happen all the time. So repeat, and then from maths, when 1 equals 1. So it's just going to do everything that's in our loop as long as 1 equals 1, so forever, basically. But now what we're going to do is we're going to use one that I don't think we've used before, which is called repeat. Oh, yes, we have. I've literally just used it. We're going to use repeat while, but instead of saying when 1 equals 1, so forever, we're going to say repeat while this pattern is equal to 0. And if the pattern's equal to 0, then I want my LED just to be on. So you can do this, repeat while, and then use the maths again. So just like before, to say this equals 0, and then you can say while pattern equals 0. Okay, so while pattern equals 0, I want to do everything that's in this loop. And what I want to do is I just want to turn my LED on. So you remember that code's an output. My LED is connected to pin 4. You might have chosen a different pin, that's fine. So my LED will be connected to pin 4. Now, if you remember that we've often said that it's a good idea just to check that things are working, so to keep testing your code. So I'm just going to start my simulation to see if my LED does go on and I haven't put it the wrong way around or anything like that. So start my simulation, it's thinking about it, and yes, my LED is going on. That's because pattern is set to 0. Okay, so you all with me so far? Give me a wave if you're there. Ryan gave me a wave, that's fantastic. Brilliant. So what we want to do now is we want to check whether the button has been pressed, because when the button's been pressed, we want to change it from just being on to turning on and then off and then on and then off again. So we're going to use the if loop, the if block that we've used before, which you'll remember is in control. So we'll say if, pop that there, and what we're going to do is if the button has been pressed, and do you all remember how we checked if the button was pressed? So we used math. I sound very American when I say that. if the button is equal to 0, and we get our button from here. So we want to read the pin. What pin have I said? Pin 13. The button in pin 13 is 1. So we're checking if the button has been pressed. If that's 1, then I want to change my variable. So I want to, instead of setting the variable pattern to 0, I want to change it to 1. Okay, so that means if the button's pressed, it will change that variable. It'll say, hey, computer, pattern isn't 0, it's 1. All right? So that's the first bit of our code. Now we're going to cheat a little bit because we want to tell the computer, tell the Arduino what to do when pattern equals 1, which is just, we're going to make it flash. So if you click on this, if you do a right click on this bit, you'll come up with things saying duplicate or delete or help. Don't press delete because that's not what we want to do. We want to duplicate this. So that way you just get a whole another copy of all of this. All right, has everybody successfully duplicated it? And then we want to pop it underneath. So it's inside the while 1 equals 1 loop, but it's underneath the while pattern equals 0. Okay, so I'm not sure we've done that bit before. So if you want to give me a wave or raise your hands or something, just so I know that you're okay with this. Fab, I've got some waving hands. Brilliant. Jolly good. Don't know about you, but when people raise their hands, it makes you change where you are on the screen and it makes my eyes go very funny. Sorry if you think I'm looking at you cross-eyed. So we've got this bit now, and what we want to do is, instead of pattern equals 1, pattern equals 0, we want to tell it what to do when pattern equals 1. All right, so there, like that. And then what we were going to do, we was going to make it flash, weren't we? So you'll remember how we made it flash. So we had set pin 4 to high, so turn the LED on. Wait for a little bit. So I'm just going to wait for half a second, say, and then set it to low. Remember to make sure that the pin is the right number and that you change that to high to low. Then I'm going to wait again so that it changes like that. Okay, so that will turn it on, wait for a bit, then turn it off, and then wait for another bit. Okay, does that make sense to everybody? Yeah, fab. Definitely made sense to Dane. He gave me a really big nod then. All right, we want to check that the button is pressed again so that we can switch back to just being on. But instead of if the button is pressed, we don't want to change pattern to 1. We want to change it back to 0. Remember, so that we'll go back to doing this. Like that. Okay, now we've just got one more piece of code to do before we're ready to simulate it and see what mistakes I've made, because I always make a mistake when I'm doing coding. So if you'll see here, this bit, this will take a whole second to run through the code before it gets to checking whether the button has been pressed. Yeah. So what we should do is we want to wait another second when the button, when the light's on, so that takes the same amount of time to get to the checking if the button is pressed as this one. Okay, and that will just mean that you need to press the button, that to switch between them, you have to keep the button held for the same amount of time. Okay. All right. Now that's the fastest I've ever made any code on this thing. So I've probably made a mistake somewhere, but I really want to get to the bit that Sarah's going to do in a minute because it's going to be really fun. So is everybody there with me? Has everybody got this weight in there? Brilliant. I can see some nodding hands, some nodding heads rather, not nodding hands. I don't know what a nodding hand would look like. I've got some raised hands. Fantastic. Brilliant. Oh, you're all doing so well. I know that I'm going through this really quickly. So if you do have any questions now, do pop them in the chat. Sarah and Ryan will, I'm sure, be able to help you. Fab. So I'm just going to test this out now. So I'm going to start my simulation. Keep your fingers crossed for me. All right, so pattern is 0 and my LED is on. So what should happen if I press and hold the button for a little bit, it should change to flashing. All right, so I'm going to press and hold the button. And now my LED is flashing. Hooray! And then I'm going to see if it will go back the other way. So if I press and hold the button, it's gone back to being on all the time. And I can do it again. And then it's flashing, and then on, and then it's on. So by using variables, we can get the computer to remember what it's supposed to be doing. So whether it's supposed to be flashing or whether it's supposed to be on all the time. And that is how you can use it to control and make like a flashing. So you know when you've got Christmas tree lights, you've often got 4 or 5 different settings. You can make it just be on, you can make it go really, really crazy, really, really fast, or you can do it nice and gently. And so using this kind of code, you'll be able to have lots of different patterns, and you can choose which pattern you feel like for that particular night. Okay, you could also do this so that you could, instead of using a button, you could use a button and a photoresistor, so that if it was dark, you could then press the button, and if it was dark, your LEDs would go on, but if you decided you didn't want any LEDs on, you could press the button to turn them off. Okay? Fantastic. Well done, everybody. I hope you all have some beautiful patterned lights. If you don't, pop a question in the chat and we will see what we can do to help. But I'm now going to hand over to Sarah because she is going to show us something really cool that we can do using some other stuff. So Sarah, you ready?
Hello. Okay, we'll give this a go. I'm just going to switch my webcam to hopefully be my phone instead. Give me just a moment. Okay, so hopefully you can now see my hands. So I've now got to remember where the camera is. So what we're going to try and do, oh, here's the camera. It's weird, is turn, sorry, this was bound to go wrong, wasn't it? A string of LED lights, so like fairy lights, if you get the right kind, you can attach them to your Arduino and use the code that you've already written to add things. So here I've got a string of LEDs, and this is attached to a double A battery pack. So 2 AA's means that it is 3 volts, which means that it is safe to use on our Arduino. If you've got some fairy lights that are attached to a plug that you would plug into the wall, then we don't know that those are safe to use in Arduino, so don't try and use any of those, but these ones should work. So if I turn on the battery, my LEDs come on. Sorry, this is very blurry, everybody, but hopefully you'll see what I mean. And I can turn them off. So we know this is safe to use with the Arduino. The other thing I'll say is I'm going to cut the battery pack off this in a moment, which means that it then won't work with the batteries anymore. So don't use any fairy lights that you find lying around in your house. Do check who they belong to and make sure they don't mind you cutting the battery pack off, because they won't be able to use them for their intended purpose anymore. So you can, oh, one more thing about my LEDs. I don't know if you can quite see this, but this is all metal. And the reason this doesn't stop working, I don't know if you've tried putting your LED, one of the ones in your boxes, if you touch the 2 legs together, it stops working in your circuit. The reason this still works is because it's coated in some plastic or some enamel that you can't see. So if we cut this wire here on the metal, it won't work, or it will, but it'll be really, really annoying to get it working. So we want to get to a bit that's got lots of plastic coated. yes, 3 AA's would work as well, Lewis, because that would be 4.5 volts. And I think anything up to 5 or 6 should be okay on the Arduino, but I will double check. So I'm going to cut this, and I'm going to cut it with, I've got some wire cutters that look like this, but you could also use some scissors. I'm not sure what I've done with my scissors. That's very helpful. But again, because you're cutting through wire, don't use some scissors that you need to keep sharp, because it's not going to be very great. I helpfully cut one apart earlier, so I'm going to bring this one over here. So I'm going to keep this battery pack because this is really useful. I could use this for other circuits somewhere else. And now I've got a string of LEDs that have a loose end, and we've got 2 bits of wire that can now go into our circuit. I was going to show you how to get the ends off using scissors, but I can't find my scissors. You need a grown-up to do this if you're using scissors. If you're using special wire cutters, then they're made to pull. Sorry, this is extremely blurry. Hopefully you can see what I'm doing. I've got a bit of metal and then it turns into the plastic. If you use scissors, you have to be very careful to cut just through the plastic and not all the way through to the metal inside, because we want to get to this metal, because this is what we're going to attach into our breadboard. So I'm going to do that on the other one. So I've now got 2 wires that are like the ends of an LED, but I don't know which is the positive and which one is the negative, because unlike the ones that come in your pack, we've not got one long leg and one short leg. So what I'm going to do is get my Arduino that I coded earlier. I'm going to plug it in, turn it on. Here we go. So I've created a circuit earlier. I'm getting it all tangled now, one moment. So this is turning on, it's flashing. So I'm going to turn off my Arduino again, because I'm going to mess with the circuit. So I don't want to start taking components out while it's still on. I'm going to pull this LED out, and in its place, I'm going to put this new wire. It's a little bit fiddly because it's lots of little strands that come apart. So you'll need to twist them together to stop them from getting all tangled. But if you're really careful, you can then put them into the breadboard. And I might have got this the right way around, or I might not have. We will find out in a moment. And if I have, once you work out which way is the right way around, it's really useful to put a little label on it so that you remember for next time. So nothing is happening. So what I'm going to do is turn it back off again and take it out, flip it over, and try it the other way around. So it must be that I put the ground into the wrong spot. So let's try it again. This did work earlier, so if it doesn't work, I'm very sorry. It's just because you're all watching. Always the way it goes. Oh dear me, can't get it back in now. So let's put one in. It's really dark. I'm going to move it away from this camera and put it so that I can see what I'm doing. So sorry about that, everyone. Okay, that is connected. Plug in my Arduino. So this is a little bit more fiddly than using the LEDs that come in your pack. They won't stay quite as neatly in the breadboard, but aha! So I don't know if you can quite see this, but my LEDs are now flashing the same way that the other one was. So what we've got now is, I'm going to switch back to my other camera. I'm very nearly finished. So, oh, it's all come apart again. But what I was having was this long string of LEDs, sorry about my background, everybody, is now going to flash to the same pattern that you coded on your Arduino to flash just one single LED. And it's a little bit dull, so I might then start adjusting the resistor, try and make it a little bit brighter, but also there's quite a few LEDs on here, so it's always going to be a little bit less bright than if you're powering just one LED. So hopefully that gives you some idea of how you can add other things to your Arduino and make your lanterns even cooler using the code that Sophie's been showing you and some extra things that you might already have lying around. So I'll pass back over to Sophie. We'll see.
Fab, thank you, Sarah. Sorry, I've lost where I am. I love that we could do all of these cool things. There were a couple of questions in the chat about this that's probably good for everyone to hear the answers to. Is it safe to use fairy lights with 3 AA batteries instead of just 2?
I would say yes. I can't remember exactly what range you can use with the Arduino, but anything up to 5 volts should be fine. I would say.
Yeah, that's what I would say, because that's about 4.5 volts. Ryan, as our electronics engineer, do we think that's okay?
Yeah, I would agree. Yeah, because you just have to change you play around with the resistor you use basically to get it.
Fab. And Lewis has said that could you use pliers to cut the wire?
Pliers might be difficult because what we're trying to do is cut the outer bit of plastic and keep the inner bit of metal. So pliers will pull, but what you want to do before pulling is cut the plastic. So if you're really gentle with the scissors, but it's quite easy to slip when you're doing it. So that's why I said grown-ups should do it with the scissors, because it is really fiddly. And if you're not careful, you can just, yeah, you can push the scissors. It's not easy with the scissors, so you've got to be really, really careful. But what you're trying to do is get to the metal bit. And
Yes.
Sophie, a few people would like to see the code back. If there's a way we can leave that up on the screen while we're talking.
We can, hang on. That's the right code. Okay, can everybody see that? Just make it a bit bigger for you. There we go. We can share this code with you afterwards as well. Thank you so much, Sarah. That was awesome. Now we have come to the bit that I have been looking forward to the most. So if you would like, we would love to see the different lanterns you've made or the circuits you've made, and just see what kind of exciting and beautiful things that you've come up with. And while we're doing that, do feel free to keep putting things in the chat, and I will leave the code up so that you can keep having a look at that. But would anybody like to share their lantern? You don't have to do this at all, but I can see some amazing ones. Oh, wow. Oh my goodness. The skull is a bit
so
scary.
Good.
I'm a bit of a wimp. Oh, look at the beautiful, is that a raven, Caroline and Lucy? Or is it a rob? I'm not very good at birds. Oh, and the tree. These are astonishing. Wow.
Well, that's a good pair of on T and E over there. It's pretty good.
Yeah.
Good cut out work.
Oh, and Ben, that's beautiful. Rudra, oh, you use the milk bottle carton like Tommy showed you. I can't see where Tommy, I've lost Tommy, but
Great.
oh,
Just
there you are,
good.
Tommy.
See a Lego house.
Oh, and so have you, Ben. Oh, there's a Lego house. Wow. Oh, and that's beautiful, Dragonfly.
Wow.
Look, you can see the
Amazing.
thing.
Come through the window. That's brilliant. Yeah.
Oh
I
my
can
gosh,
see
and
someone's got a fairy light string. Is that right? Dragonfly, is that?
I think so. Oh, we've got more Lego houses. And Stuart, that is beautiful.
Looking really good. Looking really good, guys. Really impressed.
Wow, I am so impressed with all of you.
We use the RBG LED, so the multi-color changing one. The one LED making loads of different lights, if I can remember.
Fantastic. Oh,
So how do we share all these brilliant lanterns that everyone's made. Is this a time for Catherine to talk about the Christmas Light Festival, I wonder?
I think that's a great idea, Dane.
Hello.
Sorry, one second, Catherine. I think Sharia was going to show,
Oh.
wanted to show one
Yes.
as well.
So
Just want to hold it up.
Pardon?
Just want to hold it up.
Yeah. So what I made over the weekend, I tried to make something. It's not really. It's kind of like a beta version. However, it's kind of like it's a thing where like there's a row of 12 LEDs, and it's meant to like be like a clock showing what hour it is. Like each LED flashes every hour, so each LED is a different hour, and every hour I have a buzzer on here, if you can see over here, and this buzzer goes off every hour. However, I've tested it low scale, and it usually it goes off at every minute. So if I turn it on, it'll be like showing the first hour. Like, look, so the first LED's gone off, and it's gonna have a buzz. If you can you hear that? There was a little buzz, and that so it's a bit like a clock, and it basically it shows like what time of the day it is.
Good work.
That's amazing, Sharia. Thank you. Honestly,
cool.
I love that the Caroline and Lucy's people are having a disco.
Great
Um,
disco.
I love the star and moon. Oh, this is just. I'm so amazed. So I think, as Dane said, it's now a really good time to hand over to Catherine, because you've done such amazing work that I think it definitely deserves to be shared with more than just us. So Catherine, how can they do that?
Yes. I just removed all the cables that I had all over the place. I was gonna screen share, but then people cannot see the code.
We can
We
start.
can start sharing the code for a second. Yeah.
Okay, cool. Yeah, there you are. Oh gosh, I'm so sorry. I have a new computer. I have to allow Zoom first. I can't. Oh, I cannot screen share. I haven't used this computer before. I'm sorry.
Okay, I can share my screen, which has the Light Festival on.
Oh, fantastic. Thank you, Dane. It's yeah, we have all been making like incredible amounts of different sort of lanterns this year, and of course, for those who know the Oxford Christmas Light Fest, it's usually a weekend full of activities in this Oxford city centre. This year, because of the circumstances, we actually got the chance to bring the celebrations out into the neighborhoods and out into your community. So I want to encourage everyone to share what you made by sticking it into your window and marking yourself onto the light trails. Dane is showing. So basically what happens if you sign up for the light trail is there is going to be a little pin that appears on the map, the Oxford map, and then you see a lot of people have already registered. And it won't show your address. It only shows people that are out on a walk anyways, that there is a street where they're very likely to see a lot of brilliant homemade lanterns and homemade LED displays and stained glass windows and all kinds of things that people have been making. So yeah, I would encourage everyone to just take part in this to light up whole Oxford.
Thank you, Catherine. We've had a couple of questions. What if they don't live in Oxford? So is there a way that they can share it online at the festival?
Yes.
Part of the festival?
Thank you for pointing that out. Yes. So if you would just like to share it with the gallery, you can share your picture with on Instagram using the official hashtag, which is hashtag #BeTheLight and hashtag Ox Lightfest 20, and then I think after review it should just pop up in this gallery. So you can see last Saturday we made some owl-shaped lanterns in a workshop hosted by Fusion Arts. There is another workshop this Saturday, so you can sign up. I will pop the link into the chat in a minute. Yeah, so if you don't live in Oxford, still please share your creations with us and just use the hashtags. Yeah.
And I think you can also email your photos to oxfordlightfestival@gmail.com. So there's an email address just here, which I'm just going to highlight. Hopefully that's worked. And if you don't have an Instagram account, for instance, that's no problem. You can just email your photograph of your lantern to oxfordslightfestival@gmail.com. And if you put the subject header to be photocomp, festival make, or photocomp #be the light, it could be a way for getting your brilliant photo of your lantern up on the gallery too.
And maybe you win a prize.
And maybe you win a prize. Yeah.
There is three prizes are going to be given out for the best make chosen by different parties. So I know, as a matter of fact, that one of those prizes is a covered market hamper, which I would be very excited to win. So.
And if you want to email your photos to Sophie and Catherine and me, you can do that too. So if you want to send it to info@ or just send it to Dane at if-oxford.com, we can get images of the lanterns put on our social media as a story or as a kind of group effort. So I'm going to stop sharing my screen now so you can.
Thank you, Dane.
So thanks, Catherine, for that summary of what people can do. We've done so much. I can't believe how much progress we've made in just 6 weeks. We've got people going from, it's almost like a piece of coding, isn't it? So while 1 = 0, we're not doing any coding, but while 1 = 1, we're making lanterns. So we've done a huge amount in just 6 weeks, literally going from a box of wires and not knowing how to use Tinkercad, all the way through to producing lanterns. Oh, I forgot to show my lantern as well, actually. Sorry, I forgot about that. So I made a little lantern too. Where is it? I'm just going to put it. Here we go. So I've got some willow, and this is my rainbow-coloured flashing light and willow lantern from Fusion. So there's plenty of inspiration. So please do send your photos. Please keep on tinkering. We've got to the end of the session, I think, at 5:15. But if anyone's having real problems, we can just do a quick 10 minutes of emergency coding. We won't be extending with new hints and tips. I think we just want to get people doing this pattern session, or if there's been something that's been a problem in the past 5 sessions, we can help there. So if you'd like to stay and watch that bit of troubleshooting, please do. If not, it's been a real pleasure. So thanks, everyone. Thanks, Fusion. Thanks, Raoul. Thanks, Tommy. Thanks all the people that Sophie's brought from STFC's Raoul Space, looking at lasers, looking at arts and science, looking at kind of engineering and how we kind of optimize kind of light. So a huge big thanks to Sophie. So maybe we could do a little round of applause to our coding team. I'm going to thank people now. So thanks, everybody, and well done, everybody. Of course, and thanks for Sarah for troubleshooting. I think we wouldn't have been able to do it without Sarah from Science Oxford. Gosh, that's an error from me. Thanks ever so much, Sarah. Yeah, brilliant. Well done, everybody. Please do give feedback. We always want to know how this worked. I think it's worked better than I thought, actually, in some ways. So I think if people want to do this sort of thing next year, we'll do a similar sort of thing for if Oxford's 30th birthday in October 2021. Wow. So thank you for joining this experiment.